Good morning, everyone. Welcome to the Rackspace webinars. Today we'll be talking about the launch of the Rackspace in Hong Kong, and give you a little bit of introduction into our Rackspace Cloud. So, with any further ado, let's get started. So, a little bit about cloud computing. I did a little bit of research around the internet, and the one that I found that I really liked more was the rental car analogy to explain what it is, this new hype, which is cloud computing. So, a rental car, they are available when you want them and where you want them. You just pick the car from wherever you want, from the airport, from the closest rental, and it's a little bit the same with the cloud. You can have a server up and running when you want it, where you want it, around the world. You only pay for the time you use it. Exactly the same thing, right? You rent the car for a couple of weeks, or a week, or weekend, and you don't own the car. You just pay for that time. And the reason is the rental car is the real owner of the car, as the cloud provider will be the real owner of the hardware where your cloud server is sitting on top. Booking should be easy. So signing up is a process. A very straightforward process. There won't be no contracts. You get a login. You start using it, and you can use the internet using a very easy web portal, or you could use an API through scripts that would take some time investigating on setting up initially. But once it's done, you can just move on. A large number of vehicles are available. So the same way when you are choosing the rental car, you might choose a little bit around the purpose you want. So if you need to do a move from your house, you might rent a big truck, or if you want to deliver some merchandise, and you have a large order, you might rent a couple more trucks. You really choose the right car for the right job. The same thing with the server. The cloud server, you can choose the right server size, the right server configuration to do the job or to handle the workloads that you need. You can buy more cars, and in this case, it should be rent more cars if there are many requests. So again, it's the cloud provider that handles the hardware, so you don't need to really worry if there is or not hardware available. You just provision, I need 10 servers, I need 20 servers, I need 1,000 servers, and it's just the time for them to building. You are not worried about what hardware is running under and supporting those servers. So why should you care about this technology, really? You've been running all your infrastructure in the same way. Everything is fine or not. Why should I really care about running this? I mean, most small businesses or startups, they really don't have the financials or the expertise to run cloud computing. And to say as a small business or startups, enterprises also. So why not deliver this kind of workloads to experts? You only need to worry about getting the servers up and running. You don't need to worry about networking. You don't need to worry about programming. You don't need to worry about patching or maintaining or solving any issues with the virtualization and cloud computing layer. You just consume the resources. But this is not just for small or startups. I mean, enterprises even the ones that are well established, or the ones that are going into well established, they need to keep their competitive edge and competitive advantage. And the only way to keep in a market nowadays is to keep focusing their efforts into innovation. Now innovation requires a lot of effort internally to keep up with the new technologies, to keep up with the new trends, to keep up with new ways of doing things. And why not also have those resources immediately available? And some things that some organizations should definitely ask is to have an idea. Do you have an idea how long it takes to deploy a new infrastructure or grow your existing assets? I mean, this is very critical, because if you are facing peaks of usage and it takes days to provision a new infrastructure, this means that your clients are going to get a poor customer experience. Or even projects that have a green light to go might take weeks or days to even start. So the cloud, because you can spin the instances in minutes, really gives you that flexibility. Another thing is, because of that time, one of the consequences is for you to suffer from the shadow IT, which is a phenomenon where because it takes so long to provision resources, our employees will find ways, because they are achievers and they want to go ahead with the deadlines or go ahead with their objectives. Of course, they find ways to build their own IT resources, and sometimes they fall outside the regulations of the organization, putting in risk their security or putting in risk their own assets. So having that fast time to provision would be really a big answer for you. And another thing is, cloud allows you to shift from having to maintain maintain and support your organization, and focusing your costs into support and maintain, into focusing your costs into innovation. Now, if you start spending less with your IT in support and in maintenance, you can use that extra financial to hire developers, which will allow you to shift from maintenance to innovation, which is something that is really critical for all your infrastructure. And then optimizing costs is basically you only use what you need, opposed to have that waste of computing just sitting around in your infrastructure. So cloud computing has a little bit shift on the thinking. I mean, reasons why cloud computing is driving this is the organizations need to increase the percentage of infrastructure they outsource. This is a shift on thinking with public cloud. And companies that are adopting cloud, they are becoming more competitive. Well, why? Its ability to use, consume from your desktop or mobile. It's really fast and easy, and right in your fingertips. You don't need to have more expensive deployments where you need to train people, you need to train to buy hardware, to buy software. It's all there on demand, and you switch it on, switch it off. It's shifting into IT as a service. You rent IT as a service instead of buying it. Rackspace will manage the infrastructure from the network to the hypervisor to your infrastructure as a service, your platform as a service, your software as a service. All you need to do is select what you want to consume and how you want to consume it. Now, renting technology carries less investment costs, but utility-based model and no contracts upfront, which is really one of the main drivers. By doing this, you can increase IT agility to address changing business needs. Rent the infrastructure, hire more developers. Gain transparency and control over costs. You rent the infrastructure, you choose how much you are going to spend, and you also can choose what your breaking point, how much you want to scale. It's that easy. Yes. Let's have a look here. A quick demo on one of our all right. Let's have a look here. One of our newest products, which is cloud deployments. We are seeing here the web control panel for the Rackspace Cloud. I'm going to create deployments, and what cloud deployments is, he has predefined blueprints for infrastructures that I might want to create, and this actually is something that is growing. As you can see here, we have several. As you can see, we have several already blueprints for WordPress, Chef Server, Django, Ruby, PHP, Jenkins, Magento, IPython, MongoDB, SaltStack. So, and we are adding more and more as we go. In this case, I'm going to choose. I'm going to build 20 servers with a load balancer behind them to balance the load across all of them, and I'm going to also build a database server. So this will allow me to have an up and running PHP web farm in a couple of minutes. So all I need to do is really give it a name, select the zone. In this case, I have 4 zones. After the call launch, Hong Kong will be also available here. I'll be creating in Sydney. Here I would just put the URL for my website. This will be reflecting on my Apache configuration. Just I invented one. I can install Varnish if I want. I could put here my Git repo to pull my code on from. Any other packages that I wanted to install by default. And if there was any configurations that I wanted to change, like what would be the ports, memcache memory, I'm going to put 128 here. That's it. Next step, number of servers, I'll put 20, and I'll select the database server with 1 giga. Load balancer will be created. I click and create deployment. And my deployment is going. As you can see here, my deployment is going on progress. I already have these 3 servers here. All my servers have been put in the queue and are being built as we speak. And now I can go back to my presentation while they are building. So we talked about this optimizing costs, not only by only choosing what you are consuming, but it's also about matching costs to demand. So now in traditional IT, what we see is the CapEx model. What it means is you buy the hardware and you own the hardware. And usually what you see here is I'll be highlighting is when your usage goes up, you are always provisioning ahead of that usage, so that you have enough or more capacity to handle that. And what happens is here, as I'm highlighting here at yellow, you get all that over that waste. So at the yellow you can see all that waste. And what to do with that waste? Well, nothing really. You just because it takes so much time to provision. You have to keep that waste, and usually owning your hardware. It's only not just buying the hardware; it's maintaining the hardware, and is also having to pay for electricity, having to pay for network, setting up everything, and this hardware, as soon as you get it delivered, it's losing the value. And then it happens the phenomenon when, as I'm highlighting at blue, you have a sudden spike on your website or on your application, and you, by any reasons, your projections didn't foresee this, so you are under capacity, which makes your clients to have a poor customer experience. On the other hand, you can then have the OPEX model. So the OPEX model really is going to allow you to just be a little bit above what you need, but you are very close to the what you need to consume. This optimizes your costs, and allows that your infrastructure accompanies the curve, keeps close to the curve of your usage, and optimizes your costs. So you are not having waste, so you are not over capacity, or you are not under capacity. And this can be achieved by using auto-scaling tools that incorporate with your cloud infrastructure, that monitor and trigger events to scale up or down your infrastructure. So why did we choose OpenStack? Why Rackspace choose OpenStack to be the engine running their public cloud, and why is it open source? I mean, first we joined this project with NASA, with two projects, with Nova and Swift, and in fact those were the projects behind in the beginning of OpenStack. Now, if you look at this column here, this is some of the projects that are now in place. So we started with two in 2010. As you can see, the number of projects, which means the number of features and the number of technology involved, has increased significantly. So this is only a couple of them. Nova being the compute, and for instance, Keystone authentication, EAT for automation, Neutron for networks, so on and so forth. So it's really growing really fast. And another reason, with just 2010, we are founded by Rackspace and NASA in 2010, and a couple of partners. We are currently on the 7th stable release, with a new Havana coming probably before the end of this year. So it's really growing really fast. And the reason why it's getting this traction is because it has a strong community, strong contribution. So as you can see for this graphic here, you can see the number of commits and the evolution of commits throughout the period of a little bit more than 2 years. So it's really growing in numbers of code and numbers of commits. The reason, also another of the reasons, is by giving back the community and opening this awesome product. We are also seeing that behind this project, there's names, there's Rackspace of Red Hat, Mirantis, HP, Nebula, EVM, Yahoo, Puppet Labs, and others looking at, such as VMware, or even Microsoft, looking into this project. So it really has a lot of traction within the community and within the technology. So this technology is changing the way we provision, manage, and architect IT, such be it at the reach of any organization or individual. and that's why we want, because this is shaping the way we are using IT, shaping the way mankind is consuming IT. This has a great impact, a positive impact for mankind. There's no vendor lock-in, so the big advantage is you can move your workloads around OpenStack providers, which is a great thing. You can fork the project and adapt and develop, tailor it to your own needs. I mean, anyone can contribute. If you want to see out of the community a feature which is really cool and really brings value to everyone, you can actually lobby within the community and influence to get it done. There is a lot of momentum behind it, and the main reasons are things such as being a strong community, growing every day, and this allows you to prevent you from being locked into the cloud provider technology. So we at Rackspace, we are experts in OpenStack. We have one of the largest public cloud deployments around the world. We have contributed with thousands of lines of code, and we are still doing those contributions. And that's why I believe with our expertise and using the rental car analogy again on the way you consume public cloud, letting us run the infrastructure for you with 24/7, 365 fanatical support on top. Really, we are the partners for you to run your cloud infrastructure and to give you the ease and peace of mind that you will be running it smoothly. On that note, OpenStack Summit is coming to Hong Kong, and will be in November, around the 5th and 8th, if I'm not mistaken, and quite exciting news. So, Rackspace DCs are scattered around the globe. We have Sydney, Hong Kong, London, Chicago, Dallas, and all of them with cloud. And this month we'll be seeing Hong Kong launching their own cloud here. So in this with this last launch of cloud in Hong Kong, you can choose from a broad range of locations to create your own infrastructure or to deploy where your customer base is. I mean, I've seen customers that are based in London, but the big footprints of customers were located close to Dallas from Brazil. So there's that flexibility where you can deploy geographically where you need to. So we'll be launching in Hong Kong a full product spec of our products and services, making sure that we are aligned with all other DCs with cloud. So whenever you build a server in Chicago or build a server in Hong Kong or in Sydney, it will be exactly the same. And using the same API, the same method, you just point it to a different zone. So now let's have a look at the cloud server instances. What they are Linux or Windows servers. You can either scale them vertically or horizontally, which means vertically is by increasing the size of the service. This is useful for some applications where they cannot support multi-node scaling. And horizontally by creating an image that then allows you to clone your servers and add more servers to your running infrastructure. And once you no longer need those servers, you just delete them. It's very easy. You can do this using either the API or using the web control panel. But if you do so by using the API, it really leverages the automation, which will make your administration and maintenance much easier. So let's do a little demo. So as you can see here, on almost all my servers are already built. So 11 minutes took it 11 minutes to spin the server. Now let's take a closer look. So I just did a demonstration with an automation. Oh, okay, seems like all of them are built. And now I'll go to just creating a server where I will create a server now in Northern Virginia, and I just need to edit the name, select the zone. I can select from a saved image. There's none. There's no saved images, but I could create easily an image of any server. I have this server here. I will create an image really quickly. Okay. Create server. As I was explaining, I can select here an OS version from this extents list. In this case, I will be creating a Windows 2012. I created an Ubuntu before. I'm creating now Windows 2012. If I wanted to create from already created server, I could select one of these images here available to me. Okay, actually, I'm going to build. Yeah. So Windows 2012, and immediately here I can select a flavor by moving this up and down, and automatically as I'm moving down it's telling me how much the price is, what is the network bandwidth, what's the RAM and the CPU. So the bigger the size is, the more CPU, the more RAM. I get up to 8 virtual CPUs and 30 gigs. In this case, I'm creating 1 gig server. I can add a cloud network, which is a private network, so I can connect several servers to this network. And it's that easy by just creating a network, adding the private range. You can be any private range. I'll just leave the default options and create a server. A password appears. I can change this password later on. So let's leave it there building. Okay, so let's move on. So having several servers need to have some sort of device to control the traffic in front of the servers. So this is where cloud load balancers come in. So they receive the traffic and then they distribute the traffic across whatever is behind them. And load balance the traffic between. So they are built with the robust technology of OpenStack and Stingray for the load balancer appliances. They sit on a cluster, so there is no single point of failure within the cloud load balancers. But and as the traffic increases, you can have behind them any number of cloud servers. And the load balancer will work as a traffic manager, will distributing the load according to algorithm that you choose across all of them. But What happens if one of the servers by any reason fails? The load balancer also detects the node as failed and stops sending traffic to that node and keeps only traffic going to the available nodes. So this is also useful for HA and of course, for load balancing. And you can also install SSL termination or other more advanced load balancer configurations. And it's that easy to build. So I'm actually going to go and do a little bit demo on how to create a load balancer. I used to say that even my 7-year-old niece can create resources here here at the Rackspace web control panel. So we go to the load balancers. As you can see, this is the load balancer for the servers I created with my cloud deployment. And I'll create a load balancer. I just need to select the load balancer, select the same area where I am. In this case, I'm creating a server in IAT. I can select if it's a public, accessible, or internal, or sharing the IP with another load balancer. I select the role algorithm. The most used is actually round robin, which is evenly distributed sessions. And I can add my cloud servers. In this case, it's my still building server here. And I could change the destination port. So if I wanted to use port translation, that will be fine. Once the load balancer is created, I can also add external nodes. So it's not just thought around cloud servers. If you want to have other servers being balanced through here, it's perfectly possible. And all I need to do is create a load balancer. And there's several other options that will be available once the actually it's already built, as you can see. So I could add an external node, any IP that I want to, and I can change health monitoring. I can set up connection throttling if I want to, set session persistence, content caching, which is just enable, and it can be controlled to the API what you cache or not. SSL, I could put my cert here if I wanted to, configure my own default error page, which could be in more crafty way a redirect to whatever I want it to be, and even set access control if needed be. So it's really easy, really straightforward. Cloud monitoring. I mean, of course, you have your infrastructure with all your compute running, but we all know that hardware can fail, software can fail. So the better way to prevent this is by knowing exactly what's happening with our infrastructure. So again, Rackspace Cloud Monitoring allows you to monitor your servers. So that you proactively or reactively can keep your infrastructure up and running all the time. And it does this by having checks scattered around all our DCs that either through the web or from the local DC where your cloud servers are located, it will be monitoring your servers. And this allows your IT staff to focus on other tasks instead of going every day checking graphs or checking if everything is running or not. So you can monitor remote ports such as HTTP or a specific port, or even sending a ping, or you can go into the detail of monitoring CPU, memory, disk, network, etc. Or you can even create your own custom ones. One of the ones that is most famous is to monitor, for instance, MySQL master slave replication. Because you have an API, again, you can easily configure and automate all of this. So, and of course, one big advantage of having the managed service level. So we do have two service levels in the cloud. We have the core cloud and the managed cloud service level. So the core cloud, we see it more comparable to managed colocation. So we don't log into to your cloud service. We just maintain the infrastructure where your cloud servers are running. While managed cloud, we will log into your servers and we will manage them for you. So the intention behind we have a user support, and the idea behind it is we manage the operating system, and it will leave the customer to the responsibility of managing the application. And when we say we manage the operating system, we look after things like the patches, setting up the web server, configuring the SQL server, creating websites, creating users, installing software from the operating system, those kind of tasks. While your code or your proprietary application will be your responsibility. So just have a look at a little bit of these metrics that we are talking about. So I actually have a server with my servers seem to be all built. Even my Windows server is already ready. I can now change here the password. And I have here a server that I already set it up a couple of monitoring alerts. So one thing that the monitoring gives you immediately is you can see RAM, disk, and CPU being consumed in real time, and have a look at the running processes and memory they are consuming here. We also can have some information regarding your usage. So as you can see here, this is the line of the red line. So my system is almost not being used at all. I can monitor also the load average, which is really slow. My memory is flat. There's not much information there. Network activity, now we can see some network activity here. Probably some connections. And I can see my ping information. So I'm also monitoring, doing pings to the server. And because my server is being monitored from several zones, so this server is actually located in Sydney. And I'm seeing here that from Dallas there was some packet loss. Here from London, Chicago, not really. There's nothing to report. So probably the provider here adds a hiccup, and I will register some. And creating a check is just as easy as going here, checking what kind of check I want. So if I had a website, I could create a HTTP check, give it a name. Put here whatever URL I want. And I can also put the body match. So I could actually make him look for a page that says good or bad, and know if really my website is up and running. All right, let's move on. So, cloud monitoring, and of course with the fanatical support 24/7, 365 with the managed service level on top, getting at the alerts and acting upon the alerts, opposed to being you getting the alert at 3 o'clock in the morning. You probably sleep. You probably will only when you check your email in the morning will know. So it's always good to have the managed service level and have somebody 24/7, 365 looking after your infrastructure. All right, cloud backup. So we spoke about image backups before in this slide. So you can use the image backups to create the copies of the server, to clone the server, to even use it to scale your infrastructure. But image backups are like a photograph in time. So if I take a photograph of the server at 8 o'clock in the morning, my server for any reason crashes at 10 o'clock in the morning, all my data that changed in between my 8 to 10 will be lost because my image backup will only have the information from 8 o'clock. So and also if I need to recover any specific file from the image backup, I need to restore the full server. So that's why cloud backup comes into the rescue. It's a file level backup product, and it allows you to selectively choose folders or files to backup. Not only this makes the backup faster, but also the time to recovery faster, and optimizes your cost into storage. So you can schedule backups, and also you will compress and duplicate any files because it uses incremental technology. So backups from whatever they are coming, which server they are coming, they are compressed. You can also choose to encrypt the files, and then they are saved into cloud files. Now, cloud files is starts at 7p per 7p per giga, around that. So they are quite it's a very low cost for giga, and it also has a redundancy embedded in itself. So it's really a good place for you to store data, and the data is being stored in a different location than your cloud server. So cloud backup definitely, and image backup, something that you should use together. So you only backups close files. If you are asking yourself image backups or cloud backup, use both. So that's it. So API. So all these products plus all of the products that I've shown you on all these products here, they have all an API, which means that all the operations that you use the web control panel to build, you can also use an API to build an entire infrastructure. And why would you use the API? API allows not only software vendors to integrate their own applications, but it allows you to introduce an orchestration layer on your infrastructure. So you can actually automate creation of servers, deployment of software, configuration of the software inside the server. And because of that, if you're using a DevOps mentality, you can actually speed up setting up new infrastructures, responding to failures. And this is really key for you to have those faster times to market. So it gives you orchestration, gives you automation, it gives you that auto scaling where you don't need to manually go there and create a server and make sure the server is operational and ready to go. With the new cloud servers, we have made the API 25 times faster to create. A good example is, for instance, the ability to create both your DNS records using a RESTful API or control panel API with us. So you could actually create manually the domain, and then each thousand of servers that you are going to add thousands of servers with 1,000 different DNS records. You could script those records automatically. and it reduces complexity on maintaining a large infrastructure. Thus reduces total cost of ownership. And we are now in the big initiative of Rackspace DevOps. So we are in a position where we can actually support you with up to the code that you are using to touch our API. I mean, we will not be managing the code for you, but if you are stuck with the parts of code that touch our API, you can come to us and we'll try our best to help you. So we are extending the support much beyond any other cloud provider is actually right now in the market. Okay. And this concludes this introduction. I would like now to open the floor to any questions, and I'll be now taking a look at